Uh, Good day, guys. Today we will discuss about plasma proteins. I had left, I think, in the last lecture that plasma proteins will be covered the next time I make a video. So we'll start directly at it. So we'll first discuss origin of plasma proteins. You have to know one thing is plasma proteins make up the plasma is made of 50, plasma makes up 55% of total blood volume. Okay, and it is 91% water, 9% solids, and of that 9% solids there's 1% which is inorganic and metals like sodium, potassium, on anions and other cations, and 7% is made by organic. Of that 7% organic, plasma protein makes up a pretty big amount, and plasma proteins play very important functions, so I'll cover them first. Origin of plasma proteins in adult life is albumin. Remember I spoke about albumin and globulin. These are the main two types of plasma proteins which are seen in blood. So this albumin makes up about 55% of total plasma proteins, and globulin makes up of about 33 to 37%. So you need to know where albumin is formed. Albumin is formed in the liver, and globulin is formed from tissue macrophages. It is formed from plasma cells, which is a type of a cell found in lymphoid follicles. We'll get to it later on, okay? And also there's a fibrinogen, which I said makes up 7% of total plasma proteins. Like it is also synthesized in liver. So if you have to know, albumin synthesized from liver, globulin is synthesized from liver, from bone marrow and spleen and tissue macrophages. Okay, then we'll move on to, first I'll take forms of globulin. Remember, globulin has actually it's three types. There's alpha globulin, there's beta globulin, there's a gamma globulin. For functionality purpose, I will just get to the basic types of globulin seen in the blood. Okay, glycoprotein. The word glyco means carbohydrate. Okay, sugar. So sugar and protein which are connected. So glycoprotein. These are a type of. This is a form of globulin. Okay. Then we move on to lipoprotein. This is very important, lipoprotein, because you must have heard about HDL cholesterol or LDL cholesterol or VLDL cholesterol. Okay, these are, what are this? We say they are like cholesterol, but it is a lipoprotein. So there is like a protein part and there's like a lipid part or a fat part. Okay, for simpler purposes, lipoprotein is a protein which is seen in blood, lipoprotein, and there are types like HDL, LDL, VLDL. Just for fact purposes, HDL is said it is like good cholesterol. Now there's a big debate whether what is really the issue with HDL, LDL and VLDL. Okay, there's like mixed research out there. I will just tell you what they could mean in usually previous textbooks and what they say. I'll just tell you. Okay, so HDL is like a good cholesterol. HDL, high density, full form is high density lipoprotein. Okay, LDL is low density lipoprotein. VLDL is very low density lipoprotein. So in previous books also it is said that LDL and VLDL, these are like bad cholesterol. They used to say that before. Now there is again mixed research, but just for you to know, I'm just telling you there's LDL, VLDL and HDL. And what they found was before that HDL was increased in people who used to exercise, like have aerobic exercises, and those who would like work out or were like less smoke, who would not smoke, who are not sedentary workers, they had HDL level, the so-called good cholesterol level, higher, and it was found that it was somewhat protective from coronary artery disease. Okay, where plaques are formed in the blood vessels or the arteries of the heart. Okay, so apparently they found this was helpful, and LDL and VLDL was detrimental, and it was said that they used to cause atherosclerosis, and in especially I would say in India and this, we still feel this, they cause atherosclerosis, but again that is a bigger topic, and I just wanted to you to know that LDL and VLDL is said that bad cholesterol. They are lipoproteins, that means lipid and protein is in joined, and it's a type of globulin, okay, which is seen. Then there will be speaking on transferrin. Okay, transferrin, the word itself tells it. Trans means transport, okay, think like that, and ferrin, this is iron. So what do you think this does? Transferrin transports iron, okay. So it is a type of globulin. We'll get to this in detail later on. Okay, just for level, how much level is 3 to 6.5 milligrams per deciliter. Okay, this is there. The functions of transferrin is that it regulates or controls how much iron is absorbed from your gastrointestinal tract, okay, and it helps in iron transport. The very fact it's transferrin, it transports iron, okay. And another one more important feature is it protects against iron intoxication, too much iron also, okay. Just I want you to remember these three first, okay. There's something called as haptoglobulins, okay, and this prevents iron loss, and it protects kidney from free hemoglobin damage, okay. We'll get to what is hemoglobin in the next lecture. There is now very important one, which is ceruloplasmin. Okay, ceruloplasmin is a globulin. It's one of a type of a globulin, which is a plasma protein, and this ceruloplasmin binds copper, okay, copper, copper, this copper metal, and transports it and helps in storage of copper. This is ceruloplasmin. So there is a disease called Wilson's disease, and what happens is there is deficient plasma protein, this globulin ceruloplasmin, which is responsible for transport and storage of copper, okay. So this is copper, it cannot it is like bound to this protein, okay. So when this is not there, when ceruloplasmin is not there, what happens to copper is it gets deposited in brain and liver, okay. This copper, when it's bound to ceruloplasmin, is less harmful, or it's not harmful. But when this ceruloplasmin is not there, there is deficiency of this plasma protein, this copper gets deposited in liver and in brain, okay, and it causes their destruction. That is called hepatolenticular degeneration. We'll get into it later on, okay. So, and that disease is called Wilson's disease, okay, just for you to know. Then there's coagulation factors. Do you know there's like a whole two pathways of how blood gets coagulated? Coagulated means like clumping or whatever, like stoppage of bleeding. A clot needs to be formed, okay. So whenever bleeding occurs, you need a clot to stop the bleeding, and that you need something called as coagulation factors. We will realize later on that, oh, to stop bleeding we need coagulation, we need to stop the blood from gushing out, and you need coagulation factors to act in a certain way, in certain pathways, such that bleeding does not occur, okay. And then when you be like, what are these coagulation factors? They are in fact a type of globulin, again like a plasma protein, okay. Yeah. So then we will move on to, we had all this immune function, immunoglobulins, okay, directly. That's a part of it's a part of this globulin. Then we move on to variations in plasma protein concentrations, okay. So when does plasma protein concentration vary? Let's talk about decrease. When does this plasma protein concentration, which is how much, 6.4 to like 7.5 grams per deciliter, if you remember I said 6.4 to 7.5, or average will be like 7.5 grams per deciliter, the plasma protein in your blood, okay. So when would it decrease, especially in hemorrhage, okay. There are many causes for decrease, many causes for increase, okay, but I would just point out the main ones which will help to remember. Hemorrhage is one, okay. Hemorrhage, blood loss. Hemorrhage is blood loss, okay, loss of blood. Why? Also loss of blood, your plasma proteins also will decrease now. So hemorrhage is one which could cause decrease. Increase is secondary to burns, okay. What happens, you have a lot of water loss and there's like dehydration, so in that cases there's a increase in plasma protein whenever you check, okay. Then we'll go to specifics, which is decrease in albumin. There are some physiological reasons. What do you mean by physiological reasons? When I say physiology is normality, that's how normal functioning. So sometime in infancy you will have less plasma protein concentration, like approximately 5 to 5.1 5.5 grams per deciliter. Usually it is above 6, right? So it is 5. Why? Because the liver is not matured yet. Remember I said albumin albumin, which was a major plasma protein, is formed in liver. And if you're in infancy, your liver is not developed yet, maturity is not attained, so you'll have lesser plasma protein concentration. Okay, then what else was there? Plasma protein, pregnancy one, globulins also decrease. That's why I think I written. Okay, then we move on to functions of plasma protein. Pathological variation. When would decrease in albumin occur in, say, a disease state? Remember chronic diseases, or say some chronic infections, or say hepatitis, liver damage, cirrhosis of liver, your albumin concentration falls. Okay, and so there are pathological states. There are many states, but just wanted to know that something happens to liver, which is the main source of albumin. Okay, then albumin concentration will vary, right? Okay, we move on to the functions of plasma proteins. Okay, and we'll go through it like briefly. So the functions is helps in coagulation of blood. Like I said, coagulation factors are plasma proteins, so they'll obviously help in coagulation of blood. And fibrinogen is also a plasma protein. Okay, fibrinogen plays an important part in clotting. And prothrombin is another one. Then we move on to second one. This helps maintain colloid osmotic pressure. To explain this is your like capillary is the smallest blood vessel. Okay, blood vessel as in the pipes through which blood flows in your body. Okay, and plasma proteins are like these small molecules which are there. Okay, because there are many in number and they are smaller in size, there is a inward pull from outside, from the interstitial space to the inside of this pipe or blood vessel. Because there is more plasma proteins inside the blood vessel, they attract fluid through the capillary. This is the capillary wall. This is a wall which separates interior and exterior, and the fluid will flow from exterior interstitial space to the inside the capillary. And there are the capillary pores here. Okay, there are pores like this. If I draw like this now, there are pores. So plasma proteins don't easily pass through these pores outside. These small molecules which I drew here, they don't easily pass through these pores to the exterior, so they remain inside the blood vessel. They remain inside these pipes, and these pores which are there, these holes, like, they make sure this fluid comes inside. When there's more plasma protein here, which is in normal situations, fluid is kept inside. Okay, most probably here. But and while other like sodium, potassium and all, they can pass through this, so they cannot maintain that force. So this colloid osmotic pressure is what, when I said that helps maintain colloid osmotic pressure, what did I mean by that? I meant that there is an inward pull inside this pipe, whatever the inside your arteries, or inside the capillaries, the blood vessels which are there, they make sure the blood is inside, the fluid is inside them, using this colloid osmotic pressure which is inside. There's something called as hydrostatic pressure which is outside. So there's a balance maintained. Okay, hydrostatic meaning the pressure which is exerted by the fluid inside onto the wall, or it will be outside force. No, that's called hydrostatic pressure. Hydrostatic pressure, the push outside. Colloid osmotic pressure is inside. Okay, colloid osmotic pressure pulls inside. Actually, why I'm saying inside, because plasma proteins are inside. Okay, there are conditions when these pores, remember these pores which I drew here, they become bigger. These pores become bigger. Say anoxia means no oxygen, inflammation. Now many other conditions where these pores become big. Now what happens, when I said these plasma proteins, just because they're inside and more in concentration, the fluid moves from area of lower concentration to higher concentration, and because this colloid osmotic pressure keeps it inside, now suddenly these pores become big. Say something happened, the plasma proteins get leaked. These all dots are leaked into the interstitial space. What will fluid do? It will follow the plasma proteins, and it will get collected in the interstitial space. And you know what happens after this? edema. This is how there is like swelling. Okay, the type of swelling like edema, because this collection of fluid in interstitial space. But this is called interstitial space, or as a exterior outside these capillaries. So if I have to summarize, how does plasma protein regulate colloid osmotic pressure? Colloid osmotic pressure is nothing but the inward pull which is formed due to the concentration of plasma proteins inside the blood vessel or capillary, such that the force of fluid moving is inside. Okay, so many a times these pores become bigger in abnormal situations. The plasma proteins get leaked into the interstitial space, fluid moves with it. Okay, remember this. We move on to viscosity. So pressure, peripherally the blood exerts pressure, so that pressure is directly proportional to the force and resistance. Okay, so what happens whenever blood is more viscous, the viscosity is attributed to the small molecules which are plasma proteins, and hence if those plasma proteins are just removed, the resistance would fall, and then the pressure, blood pressure also falls. So this peripheral resistance has a small functionality. So if I have to describe it in a much simple way, these plasma proteins, which are so many molecules, okay, they make the blood viscous. The blood viscosity is 4 to 5 times of that of water, right? I had said in the last time. So these plasma proteins regulate this resistance, peripheral resistance, which itself this is an important factor for blood pressure also. Okay, just remember that much. We'll get into blood pressure in the cardiac series, and also this is like a common sense thing. So more the amount of molecules inside say the blood vessels, that much more viscosity will increase. Okay, that's why in many conditions when there's excess of like blood proteins or anything, as a matter of fact, any molecular chemical, viscosity of blood decreases because there's more resistance towards the movement of blood from one point to another. Okay, then I had described immune function. We'll get into immunity later on. So immune function is also important function of plasma proteins. Okay, transport function, many hormones like thyroid hormones, steroid hormones, many hormones are bound to plasma proteins. Okay, and they are slowly released. That's the reservoir function. That means X amount of hormone is joined to plasma protein, and slowly fractions of that X amount are released. That's a very important reservoir function, and it has a very important function in times of starvation, when you're not eating food or any stress situations. The reservoir function is very important. Transport functions, I told, these hormones and all need to be transported from one point to another, so that's what plasma proteins do. Immune function is. And pH maintenance, plasma proteins has that COO negative group, which can accept hydrogen and all, and that's how that pH maintenance is kept well. Okay, this was just like a brief thing about plasma proteins. To understand way bigger concepts, even like a small picture moving towards that like many disease states, you will need to know just a brief about say plasma proteins. Each factor could be explained in hours and hours and hours. Okay, each factor. There must be books also on many small things of blood. So my goal through this lecture was for you to know at least like 10% through this, such that you could read a book on blood. Okay, like when you open to the plasma protein chapter, when you buy a book say, and you see what is that, where it is formed, liver is formed, globulins are from liver, bone marrow, spleen, what is the normal concentration of plasma proteins, what are the usual function of plasma proteins. So you got an idea of plasma proteins. Okay, you could add up to the idea, you could learn more. Okay, and we'll see you in the next lecture. Hope you liked it, and thank you very much for viewing. Take care.